Good afternoon. Welcome to this new video on fitting logistic regression model with the interaction effects, and I'm using Stata. So I welcome you. Let me tell you something about the data set and the model that I'm going to fit. In this model, I'm using yi as a dependent variable, which is a binary descriptive, which is a binary qualitative variable or descriptive. So it is equal to 1 if an individual is diabetic and 0 otherwise. Age is my independent variable, and that is numeric or scale or continuous variable, and health state is my categorical variable. It has 5 categories, and the sample size for this data set is 10,351. So let me go to the data file. Here is my data file. I have already uploaded it here. First of all, I'm going to describe the variables that I am using in this analysis. It is diabetes, age, health state. So this is the description. Now I will run the regression. Logistic, diabetes, and age. First I just run the regression of diabetes on age, and here is the output of my regression. This is the odds ratio for age, and this is the odds ratio for the consumption, that is the estimates for the baseline category. Now I will run the regression for age and health state. Sorry, I misspelled this, Logistic. So here is my output for the binary logistic regression using age and health state as variables, but I made one mistake. I didn't write I dot in front of this intentionally. Now Stata is treating this variable as a continuous variable. So I'll do this again and write I dot in front of health state, and this time it is using health as a categorical variable. So this is the coefficient for age, which is exactly the same, but there are 4 coefficients, that is 4 odd ratios for the 4 health categories, and Stata is taking excellent health category as a baseline, and this is the odd ratio for the baseline. After this, I would like to use the interaction effect of age and health. So I will use this plus I will write C age, that is I am telling Stata that age is exclusively my continuous variable and health state is my categorical variable, and this hashtag sign is basically the multiplication sign, and it is showing the interaction between age and health state. Now there is the output of this model. This is the command logistic, diabetes, age as a continuous variable, health as a categorical variable, and these are the main effects of age, these are the main effects of health categories, and finally these are the effects of the interaction. These are the interaction effects of age and various health categories. So let me test some assumption, and for that I will write test palm and here I will write health state, and I'm going to test whether these coefficients for the various health categories are jointly equal to 0. So this is my null hypothesis, and this is the chi-square test value, and its p-value is less than 0.05. So we reject the null hypothesis, and we conclude that these coefficients are not equal to 0, and that could get guessed from the p-value of 3 coefficients which are highly significant. Similarly, I can also test the interaction effects of age and health state, and for that I'll write I health state and interaction coefficient, C age. Now this is the null hypothesis that the interaction of health and age coefficients are jointly equal to 0, or these odds are equal to 1. So since p value is less than 0.05, so we reject this null hypothesis, and we conclude that at least one of the coefficient is significantly different from 0 or different from 1. That is the odd, at least one of the odd ratios here is different from 1, because when the odd ratio is equal to 1, then there is no relationship between the independent variable and the dependent variable. So this is the testing of some of the hypotheses. After this, I'll estimate margins for health variable, and for that I can give this command margins, comma I dot health state. Let me use another method. Go to statistics and post estimation, and here in margin analysis I'll use this, and I launch, and after this I'll use this as a health state, and I can. So these are the marginal predicted probabilities for the various categories of health. Now this is the marginal predicted probability for a person having excellent health category of having diabetes, and this is the predicted probabilities of having diabetes for the individual having very good health. This is the predicted probability for having diabetes for the person who has good health category, and so on. And finally, this is the marginal predicted probability of having diabetes for the individual having poor health category. And I can plot this, and for plotting let me go to this, and I just write this and launch, and here I'll give this health state and submit. So it gives me predictive marginal probabilities of health states with 95% confidence interval. And you see, as the health status decreases from excellent to very good to good, fair and poor, the expected marginal probability for having diabetes is going to increase. So let me go back, cancel this, and I'm doing some more analysis, and this time I am showing this with other variables, and let me write it here at age, and for the age I'll give categories. I will start with 20, and I'm telling the stata to give me the probabilities of having diabetes by health categories for different age intervals from 20 to 80 with interval of 15. So if I submit this, I'll do this, and these are my various predictions. That is the command margins health state comma at age equal 20 to 80 at the interval of 15, and that is, you can see, 1 is equal to 20, and 2 expression 2 is equal to age group of 21 to 35. This 3 age group from 36 to 50, and so on. And finally, the fifth category is up to 8 years of age, and these are the various predicted, the marginal predicted probabilities of various health categories for the various age group. And I can also show you the plot of this. So let me go to the plot, and I will launch it, and X is health category at age, and create plot defined by variable, so that should be health state, and let me check. Now this graph gives me adjusted predictions of health state with the 95% confidence interval. So you can see this one is for the poor category of health, this orange one is for the fair, this one is for the good, this one is for the very good, and this one is for the excellent. So we can compare that the marginal predicted probabilities are lower for the excellent, followed by very good, and then good, and then fair, and the marginal predicted probabilities for the poor health categories of health having diabetes are higher as compared to other group. I can also do something else. If I give it here health state, then let me see what happens. Now it gives me the predictive probabilities plot separately. This is for the excellent category, this is for the very good category, this is for the good category, this is for poor, and this is for fair. And I can show one more trick with this. If I give it here, it gives me different plots at different. So this is the adjusted probability for the poor, this is for fair, this is for good, this is for very good, and this one is for excellent health category. So this is how you can play with the interaction, but the most important one is this one, where we have age and everything in one, and I can do that again. I'll delete this, and if I write health state here, create plots by group defined by variable. So if I give health state here, now it will give me this graph, which is giving me predicted probabilities of having diabetes at various age groups for various health categories. And I can tell you this is the marginal predicted probabilities of having diabetes for